Hi everybody, welcome to my YouTube channel. Before starting the video, please don't forget to like and subscribe Beta Facts and also press the bell icon to get the latest updates. So let's get started. Number 5. Aero Ice. Aero Ice is the lightest version of ice out there. It was discovered in a simulation in 2017 by researchers at Tokuyama University in Japan during an experiment to understand how water transforms into ice. The research team created the ice when they tried to find out what happened when water freezes in the absence of pressure. The other phases of ice we have mentioned so far were created after extreme pressure was applied to water. This simulation looked at negative pressure. The scientists created Aero Ice by extracting the two atoms of oxygen in silicon dioxide, aka silica, leaving behind just the silicon. Then they replaced the silicon atom with an oxygen atom before introducing two hydrogen atoms to create ice. Number 4. Burning ice. Methane hydrates are a kind of ice that can actually burn, as in you can set it alight like a piece of paper. The ice in question contains methane. It naturally forms at certain ocean depths, in permafrost, and even in oil and gas pipelines, where it can cause blockages. That last bit is how it was discovered. Back in the 1930s, burning ice begins as compressed and frozen methane. The frozen methane is soon covered with ice, creating burning ice. Scientists consider the ice a possible source of fuel, considering that it contains lots of methane. A cubic meter of burning ice can release 160 cubic meters of methane. It's also cleaner than coal. Unfortunately, many countries cannot replace their coal with burning ice because it is difficult to extract underwater. It also becomes unstable when brought to the surface. Scientists say burning ice could also work the other way and exacerbate climate change. Number 3. Superionic Ice. Superionic ice, or ice-XVIII, is another form of ice formed by a massive increase in temperature and pressure. It is hot, black, dense, and behaves like metal. A solid cube of ice-XVIII is 4 times heavier than an equivalent solid cube of regular ice. Some scientists believe ice-XVIII may be the most common form of water in the universe, existing in ice giant planets like Uranus and Neptune. Interestingly, scientists only confirmed ice-XVIII's existence in 2019, even though it was predicted in 1988. That year, a group of scientists revealed that water would behave like metal if its temperature and pressure got high enough. Ice-XVIII only forms when the temperature is thousands of degrees and the pressure is at millions of atmospheres. Scientists confirmed ice-XVIII in an experiment in which they used powerful lasers to create shock waves that rapidly increased the temperature and pressure of a droplet of water. Scientists observed that the hydrogen and oxygen molecules in the water instantly separated as the water turned into crystalline ice. The oxygen molecules formed frozen, solid structures called cubic lattices, while the hydrogen atoms flowed like a liquid around the hardened oxygen. Number 2. Dry water. Dry water is what we get when we mix natural water with silica, with the aid of a machine. It appears and behaves like a solid even though it is 95% water. It consists of powdery sugar-like grains, which are actually regular water droplets covered with silica. The silica prevents the water from mixing and becoming liquid. Dry water was first developed in 1968 and was used in cosmetics at the time. Everyone soon forgot about it until researchers from the University of Hull, UK, reinvented it again in 2006. Scientists think dry water could be used to absorb carbon dioxide from the atmosphere. This could work, considering that dry water absorbs 3 times more carbon dioxide than regular water alone. Scientists are also considering using it for the storage and transportation of harmful chemicals. Number 1. Quantum water. In 2016, scientists at the United States Department of Energy's Oak Ridge National Laboratory created a new quantum state of water. They made the discovery by squeezing water molecules in between hexagonal beryl crystals. The massive compression increased the pressure so much that the atoms of the water molecules became misaligned, at which point the water no longer followed a number of physics laws. The molecules were able to pass through barriers at the atomic level, a behavior that is explained by quantum mechanics and referred to as tunneling. This behavior only occurs when a substance is in a quantum state. Scientists believe water often goes into quantum mode to travel through very tight spaces in rocks, soil, and even the walls of living cells.